Good morning, everybody. My name is Paul Storm. I'm from a company called Micrographics, and it is my pleasure to present to you today a webinar about steel mapping or steel member mapping between Revit and Robot. Basically, how to get your Revit model into Robot and how can you write that back again. On the agenda today, we are looking at the export from Revit to Robot, how to open the model in Robot, assigning the mapping if it is not already done, updating the model, and then also exporting from Robot back into Revit. If you have any questions as well, please just type that into the chat box and we will deal with those. Important to note, in today's webinar we'll be looking at how Revit structural members are mapped, and then this is also important if you're not operating in the typical sort of international arena like England and America, but rather in one of the smaller countries like South Africa, because there are specific libraries that have been developed for these regions. So we are working in 2022 at the moment. It is already available for 2023, and I think most people are still within Revit 1 year behind. So we're demonstrating that in the software that is most prevalent within projects at the moment. An apology, you'll find that in my case this morning I realized that there is an error, or there was an error with the cloud yesterday. Currently you'll see that my online Autodesk Construction Cloud is not getting synchronized to my hard drive through the desktop connector, and so we will not be using the cloud directly. You'll see that the Revit files can open from the cloud, but I do not have access to the folder structure to save these files onto the cloud, which of course you can do. The files you can write into your folder structure, they will synchronize back into the cloud and somebody else can then link them in. Not talking about the Revit files as such, but more the files that are exported so that somebody else can import them into Revit. So just note that at least on the cloud side, you will have access to some other document folder which would be synchronized down onto your hard drive, and you'll be able to save these files directly into the cloud and access them from your hard drive. There you can see the design collaboration folder where I'm saving some of these files, and this is the folder into which you would typically save them. In preparation for the webinar, I've done so with some files, and there you can see the SMXX, Sierra Mike X-ray X-ray. That is the format for the robot file that is synchronized between Revit and Robot. But like I said, unfortunately I will not be able to demonstrate that today, as the construction cloud is currently experiencing a few issues. So in Revit 2022, you'll see that we've got a sort of warehouse, that a bit of a sample warehouse that was created. In one of the earlier webinars, we showed how this can be taken into Advanced Steel and managed in Advanced Steel for detailing. And now we also want to show how we can bring this into Robot. One of the most important things to realize is that you should be using a specific library. So when you do load content into your model for use, in my case, you'll see that in my Autodesk library, within the English folder, there is the South African folder. Now you can also download these for your specific country. Look at Autodesk Revit version content download. You'll find that whatever country you are currently or that you are interested in, you will find this content to be downloaded off the internet. You'll see that there is a lot of content that's available to you. In South Africa, we'll find that we've got the South African content over there as well. We just download that, it runs as an exe file, and it installs into the directory into which Revit was installed. It does so via a registry key. Typical installation. If you have trouble with that, please contact us at Micrographics or ask your local BIM manager or IT specialist to help you with that. But there we can see that in the South African library there are a few folders specifically with regards to structural elements. The typical ones would be your columns and your framing. They'll have the same section properties within the steel library there. There's the South African specific ones. You'll find that they are repeated for the columns and for the framing, and that's because their categories within Revit are different. So although you'll find exactly the same sizes, and you can load more than one at a time, you'll see the sizes that you'll be able to load in between the different families. And these are very specific families, and they have something called a section name key. And that section name key is what is recognized by a robot during the mapping of the steel members. And you would then load those into your project and use them. Do not duplicate them, as they will then duplicate with the incorrect section name key, and the workflow between Revit and robot will not be a true reflection of your model, and your structural analysis will then be incorrect. So use them as they are. These sections are available for purchase within your country, and that is then where you'll get them. So whichever country you are from, install your content, load it into your Revit model, and then model up your model. Once that is done, of course, you must also go through the typical model checks to see that your analytical model at least looks good. This is a typical matchstick model that is set up, and hopefully when everything is set up correctly, you'll find that your nodes are correctly joined, and then your model will be correctly interpreted. And then in addition to that, you can also add some loads and load cases, but of course the analytical results will not be available until you do the analysis in robot. Once you've done the analysis in robot and you've brought the model back into Revit, then those analysis results will be available to you. We're not going to focus on the analysis today. We just want to show you that you can take your model through and bring it back in, but that is the essence of the exercise. Set up a matchstick model, loads and loads cases, and then bring that back into Revit so you can see what's going on. Code checking is another discipline that is practiced within robot, so that you can minimize the different types of models or types of sections that you will purchase from your supplier. Right, so that's just with regards to the structure of the model, the sections that are used, and after that we can have a look at the Analyze tab. On the Analyze tab towards the right, you will find that you've got your Structural Analysis tab, the Results Manager, and the Results Explorer. Those are for you after you have brought a robot model back into Revit. But the Structural Analysis drop down, Reinforcement Code Check, there's the one that we'll be looking at, the Robot Structural Analysis link. It's a pretty simple dialogue. We've got choices. We can send the model or update the model and the results. That's the direction of integration with Autodesk Robot Structural Analysis, and the type of integration, a direct integration, or you can also send the intermediate file. And then you've got your send options, specifically what load cases you would like to export, whether or not you're going to use self-weight. If you're going to use plain views as backgrounds or reinforcement projects, beams, columns, and spread footings, and then steel connections if you want those to go through as well. So those are optional exports if you want some extra information to go through into Robot. Also note that you've got a little help available to you here that should open you up within the Autodesk help menu. It's the easiest way to navigate there. You'll see that you've got your Robot structural analysis. Under the Analyze the Design main heading, and this is then you will find the most common help available. There are also textbooks that you can purchase, but I know I'm not a structural engineer, so I know with the engineers you typically have a much better understanding of the requirements of your models, the loads and the sizes that you would need for that building. So there's just some general information over here, what they are within Robot and within Revit, boundary conditions, materials, and so on and so forth. There are some detailed instructions as to how you would send that into Robot and how that is mapped, the mapping of the elements. If it doesn't recognize something, it will ask you to map it across. You can also add selected databases if you need. You'll see that you can add select databases of the profiles to the list, and you can select the databases if you need. Your setting up of those databases is of course something that is more advanced. And then how to update the Revit model if you bring it back, the analysis, sending the results, the integration within Revit, how to send the model to Revit if you want to send the model results through, the integration with Revit structure, updating the robot model, and integration with the Revit structure updates dialog box. Right, so there's an enormous amount that goes in here. The analysis, exploration, everything that you might want to know as an overview you will find within the help files. If you find that this is not deep enough or detailed enough for you to get the process going, then do consider buying one of the Autodesk recognized text books, and that will then help you to understand more about the structural analysis itself within a robot, and that will then help you to do your finite analysis and show that within Revit. So not only analyze but see the results within Revit after the analysis. So it's quite a big topic, and I would recommend that you get if you don't naturally come to terms with the software, then consider buying one of the textbooks that are available for purchase online. Alright, so once you've set that up, you can choose. We're going to send the model, so we're going to say, are we going to do a direct integration or to send an intermediate file? A direct integration would be something like you've got Revit and Robot open at the same time. You've already got the model that exists, and then you're just going to send the intermediate, do a direct integration. Or you can send an intermediate file, which is what we are going to do. And I'm just going to choose to save that within our webinar folder now, in the absence of the online folder that should typically be available. It does generate the events report, and you'll be able to save that report also onto your desktop for review after the fact. Right, so it's a very simple, in this case everything worked, so there's no real warnings there that we have to go and investigate, and that then saves that file, the SMXX file, within our folder. Going into Robot, you might start just with a new project. And then under your add-ins, Robot is not usually as intuitive as an interface as Revit or one of the other pieces of software, but you'll see that you've got your add-ins. Under the add-ins you have your integrations, both for Inventor frame analysis but also for Autodesk Revit structure. It looks the same as what it does in Revit. You can send the model and results, you can update the model, you can do a direct integration or send the intermediate file. That's if you want the output, or you can choose to update the model. And then you can see that it says what type of integration, either direct or update from the intermediate file. So if you change from send, it's to, and update, it's from. Again, it's got the update options that you can choose from, and then it will allow you. It's reading, and we did a direct integration now, which is of course not what I wanted to do. But you'll see that what it does is it now recognizes the steel types from within the libraries. So let's just redo that with the intermediate file. Okay, so if we insert, then we can browse to this file. And that now brings it in. If it doesn't recognize any of the sections, it will open this interface that you see over there. It does allow you to link to a database, and you'll see that there are some databases that you can insert from a library. You will see we've got Australian, British, Chinese, European, French. So the African one's already loaded, but quite a lot of content that's available there. Now everything else has already been recognized except for these purlins. That's the purlins on the roof, 125 by 50 by 20 excuse me, with a 2.5 thickness. You can see it's not assigned. And you'll also be able to see either all the ones that were mapped or the ones that were unmapped. So if you do map this one and you want to show only the unmapped ones, then you can see which ones you still have to do, or you can search. And then on the database not assigned, if we click on that, then we'll be able to choose the relevant section that we are going to use. Alright, so there we can see our standard sections. Let's collapse them quickly. There we can see the South African Institute of Steel Construction, Structural, and there we can then see the different types that we've got. So these are it's not intuitive. If you click on one of these, you'll see a little picture that comes up, so those will be your angles. And so once you get to know the coding, you'll know which ones to choose. Typically the purlins will be cold rolled. There we go, those are the cold sections, the hot rolled sections, and most of all of these depending on what's in stock with your local supplier, you'll be able to just order them from your local supplier. In our case, we're going to use the 125 by 50 by 25. That kind of looks right. And you'll go through any of the unrecognized sections in this manner. And that will then understand how to map. And you'll see that if you just want to see the unmapped ones, it will make it disappear. Those are the mapped ones. Those are all of them. And once you've done that, you can just say, okay, it does have a file menu. You can open or save these mappings as well. So if you want to remember this mapping, you can go save as within your desktop, within the webinar. And you can always load that into a different file. So if it happens to you again, then you'll know how to map them. That's within the file menu. It's very good. You can also restore your default settings, and then also on the help topics, it should take you through to the relevant advice. It says press F1, and there we can see the robot help file. So don't forget about F1, the fact that you can open the relevant help files if you want to learn how to do this, and it will have a lot of information here for you. So this, just as a piece of advice, if you want to learn Autodesk software, the help menus are usually very, very well written. You'll find that you've got some introductory items as well as tutorials where you can go and learn how to do the things that you need to do within the software. So perhaps have a look at the help files before you purchase the textbook. Alright, so once the mapping is done, we go OK, and that will now run through the model, and it will upload all of those models. Again, it's got this short report that you can write out to see if anything was wrong, and there we can see what that is. Okay, so messages or no messages, and you can save the report out into whatever you want to save that in. Let's have a look at the model. You'll see we've got two views over here, the plan view and an actual view, and this is where you'll see the model. And if we look at the view cube itself, or the view, if you look at presentation, then you can see the actual sections, and you might have to modify them somehow, and there you find them. Right. So we're going to save this file. I'm going to save it within the webinar as a robot file. And that is now saved to the desktop as well. So you could save this into the cloud, of course. Whoops, we've lost our thing. And there we go. There's our model. Alright, so while you've got this open, let's see if we can get the Revit model to update. So looking at our structure, we've got this cross bracing on the right hand side there. And let's see what happens if we get rid of some of them. Let's say we get rid of this member over there. If we delete that member, It will update that model. You'll see that it does do a bit of calculation in the background. It terms some of the other ones magenta. Now you might want to be patient with Revit and Robot and with Advanced Steel when you do modify the models like this. We'll synchronize and update the settings quickly. So the cloud interface does work at the moment for me, unless although the synchronization to the desktop doesn't. Okay, so let's see. We can obviously do another export if we want. I'm going to call that R2. And on the robot side, if you go to your add-ins, the integrator, to Revit structure, you can once again update the model from a specific file. It should now remember the mapping that you applied previously. And if it doesn't, then see if we can open that mapping. The mapping that we saved previously, there we go. And we should find on the side over there that member that we've deleted is now also not shown within Robot. So the update was successful. Let's now try a direct integration. Let's get rid of the next frame that is running over there. Again, let's just synchronize it for good measure. Taking some time. It's still not displaying the synchronization with the hard drive. Now this time let's try the direct integration. Updating of the model with a direct integration. No, this is an update from Robot. My apologies. That's from a direct integration. So if you had done some work within Robot, then you could automatically, with both of them open, then you would be able to do a direct integration. There you can see it's busy with the purlins. It's running through all of the sections. And doing it this way would be like looking up a language that you don't understand on Google, translate forward through English, and then take whatever translated and translate it back into English to understand if the context or the mapping was successful. So it's translating from Revit to Robot and from Robot to Revit, and it's using that section key code to do the mapping. It seems to be almost done. And there we go. Okay, so it seems to have taken the connections, it didn't understand what to do with those connections. So maybe when you take the file forward, you might want to include the how do you say, the joints. All right. But the mapping worked, everything looks alright, the sections, they kind of look fine. It has altered the model significantly. Alright, so just be careful of the way in which you treat these models. You can see how that connection failed there. Alright. Always when you deal with these situations, just be careful of going too complex from the beginning if you don't yet understand the process. Rather start simple and then learn how the two work with each other. Right, so we've just undone that a little bit. Let's go into our settings. Let's include the steel connections, and then let's send the model as a direct integration. That's now exporting into Robot. Again, we'll just have to wait for it to run through. We'll open the mapping again. It's updating the steel connections. So there you can see, although it's not perfect yet, we'll be able to live with that result. If we had to work the other way around, suppose we select the next frame and delete that. Let's save this model quickly. And then we want to work in the opposite direction. So from Robot into Revit, then we'll find it on the add-ins, under integration, Robot structure, on the send options. We got the steel connections unchecked, and if we do a direct integration, then we can send the model. This now goes through into Revit structure. And it's busy sending that model back into Revit. So if you change sizes, do code checking, analysis, you can choose to send the result back after the analysis. You'll be able to see the results then of those sections within Revit as well. And we'll just wait for that to complete. And again, we've got an issue with the connections. Alright, so I would suggest that you start early with the process, or maybe create a parallel model for you to work between Revit and Robot, and Revit and Advanced Steel. Because Advanced Steel is of course a detailing platform, and it can read these connections very easily and update with those element properties. Let's see if we click on this connection. I think what is happening over here, because we are working, let's just see, I just want to undo that quickly. Let's go to the structural tab under the connections, structure, we'll see that the connections are loaded in. It's quite strange to me that it doesn't realize or recognize those connections. Right, so you can also do the opposite from your Analyze tab. You can just bring that model back in, update the model, direct integration. Okay, so we're just waiting for this quickly. Alright, so definitely something going on with my connections, obviously not correct. Okay. And it just changes that into a generic connection, which is unfortunate. Alright, so I'll have to look into that for the future to make sure that the connections are coming through correctly. But from a matchstick model perspective, it understands the model. Some of the connections at least are understood. This one, for instance, that's been understood between the different platforms. And that is essentially the workflow that you would go with. Okay, and lastly, if you had calculated some results in the model, as you can see here, where we are showing some of the stresses that are in this model. They're obviously quite small. In this case, the load cases haven't been set up in such detail. And we save this model. then we'd just like to update that as well. So in our add-ins, under the integration, on the model and results, we can of course choose to send the model and the results. In the options, that all looks good. Then let's send those off. That should be fine. Right, so what it's going to do now is it's going to upload all the analytical results from Robot. And where in the past we wouldn't have been able to see the forces that impact the members, so your support forces, your bending moment diagrams, your shear force diagrams, those would not have been available for you within Revit. But after you've calculated them and you update your model, then once you click on a member, it will update, it will show you what the calculated forces are. But you can also then view that with the results manager. So we're just going to see if we can quickly update this model. It's taking a bit of time. But of course you would have to set up the load cases correctly. So I'm not sure with this model it is actually done to a high degree of accuracy. It's updating the results. Quite a lot of information that's coming through. That is the typical workflow that a engineer using Revit to do the interfacing with the other BIM disciplines would be doing. They'd be modeling in Revit, and then they'll be doing their analysis within Robot. There are, of course, other modeling packages as well that can do finite element analysis. Let's just see if this completed correctly. Yes. Okay. Just see if we've got some results that came through. So now results manager. There we can see that it updated. And then let's go to the results explorer. And let's see our forces for members. There's the reactions. Let's have a look at the forces, the moments, the displacements and the stresses. Previously we had the stresses. Okay. Let's go and have a look in the analytical view that we've set up. Let's see how that updates. So obviously it has to go through quite a bit of information, and we'll see that in a moment. That's usually what's important to engineers, are your stresses, your forces, your deformations as well. So when buildings are designed, the engineers are not only interested in whether something would be strong enough to withstand the loads that impact it, but also whether the deformation of those sections will be within acceptable limits. Okay, we can see it looks quite a bit busy. We might want to change the scale and then see what's going on. It would also be interesting to see what sort of performance is getting required of the computer. So there are no real bottlenecks, it's just a matter of going through the information at the speed at which it takes Revit. There's nothing within the computer that is currently stopping the computer from completing the task. There's no bottleneck there. There we go. So as we zoom in, let's try and see what happens if we change the scale. Let's go a little bit smaller even, 1:10. And this then allows us to see the results that are calculated for those members. But I'm sure you get the idea. You might just want to, if you want to see these types of things, then you might want to view them in Robot and not Revit. Clearly Robot is more programmed to handle these results, but you can see them within Revit. Let's look at a 1:5. Let's make it nice and small. And there we can see what something like that might look like. So we've now got our analytical results that have come into Revit. Right, so we've pretty much been through the webinar. If you have any questions, then please send them through to us as well. You can contact us here at Micrographics. And I am in Cape Town, but we've also got other specialists throughout the country, and you are most welcome to contact us at any time should you have any queries with the workflow of taking your steel model, your steel members from Revit into Robot and back from Robot into Revit, and that includes also your analytical results. Thank you for joining me, and I hope to hear from you soon. Goodbye.